Using a given decimal approximation to estimate the value of a logarithmic expression. These may be numbers 9 and 10, or maybe a different number depending on the year that you're working. Use what you learned about expanding and condensing logarithmic expressions to approximate each logarithm without a calculator. Number 9. Use log base 2 of 6 is approximately 2.5850 to approximate log base 2 of 48. Before anything else, it's important to review our expansion and condensing rules. Assuming you have the same base, the log of a product of two factors is the same thing as the log of one of those factors added to the log of the other factor. If you have a log of a divided by b, it's the same thing as log of a minus log of b, again, as long as they all have the same base. And if you have a log of a to the b, it's the same thing as b times log base x of a. Now let's look at the problem we're given. We're trying to evaluate log base 2 of 48. Well, we know that this is the same thing as saying 2 to the what equals 48. We know that 2 to the 5th is 32, and we know that 2 to the 6th is 64. So we need something that is between these in order to get 2 to some power equals 48, or log base 2 of 48. So let's start by brainstorming, because we know that we're going to somehow need to take this 48 and split it into factors or a quotient where we have a 6 and then we have some log base 2 that we know. So here's some log base 2's that we know. Log base 2 of 2 equals 1, log base 2 of 4 equals 2, log base 2 of 8 equals 3, etc. And I need to figure out how I can split this 48 into one of these that I know and 6. So I know that 48 is the same thing as 6 times 8. So let's write that. Instead of my problem, log base 2 of 48, let's write that as log base 2 of 6 times 8. Now using my rules, I can expand this so it's the same thing as log base 2 of 6 plus log base 2 of 8. Both of these can be evaluated. I'm given log base 2 of 6, which is 2.5850 rounded to the nearest 10,000th, and I know that log base 2 of 8 is 3. I can add these together without a calculator to get this sum, and I shouldn't use an equal sign here. I should use an approximation. So log base 2 of 48 is approximately 5.5850. That makes sense because I knew that I needed it to be between 5 and 6, which we showed over to the side. And I could check it on a calculator by typing log of 48 over log of 2 using the change of base. If you do check it on a calculator, don't forget that you will need to put a parenthesis around the 48 to close the parentheses in the numerator. I would suggest trying the next problem on your own before watching the video. I like to start the problem by estimating to figure out what integers my answer should be between, then brainstorming what I know in terms of other logs with the same base that I can figure out in my head, and then use my expansion and condensing rules to approximate. When you're ready, press play. I'm looking for 3 to what power equals 54 in order to evaluate. I know that 3 to the 3rd equals 27 and 3 to the 4th equals 81. So my answer is going to be between 3 and 4. Then I also know a bunch of logs with a base of 3, and I'll write them out. I've listed a few over to the side. Now, since I am trying to find log base 3 of 54, I look at my list and I say, well, I know log base 3 of 2, and I know that 2 times 27 is going to give me my 54. So I'm going to write this as log base 3 of 54, but instead of that, I'll write log base 3 of 2 times 27. This is going to give me log base 3 of 2 plus log base 3 of 27. Log base 3 of 2, they gave me the approximation, is about 0.6309, and log base 3 of 27 is 3. So therefore, my approximation of log base 3 of 54 is 3.6309. And of course, We could check this on a calculator. Now you could, of course, do these problems in multiple ways. So what if instead of writing log base 3 of 54 as log base 3 of 2 times 27, you chose to write it as log base 3 of 2 times 3 to the third? Well, then you would have had log base 3 of 2 plus log base 3 of 3 to the third, which we know is the same thing as 3 log base 3 of 3. We're going to reach the same answer because log base 3 of 2 is still approximately 0.6309. We know that log base 3 of 3 is 1, and we're multiplying it by 3. So in this case, we're going to get the same answer. Just keep in mind that for a lot of these problems, there are multiple different ways to reach your answer. That's the beauty of them. Enjoy!